Welcome to the Deep Dive. Today we're wrestling with a question that is, well, it's as profound as it is maybe unanswerable. But it sits right at the heart of philosophy, science, and our entire ethical framework.
It really does.
The question is, what is it like to be another animal?
It's the ultimate problem of other minds, but extended far beyond the comfortable confines of our own species.
Exactly. So this is our deep dive into the philosophical and scientific trenches of animal consciousness. It's a discussion that's absolutely central to how we define mind, how we acquire knowledge, and how we figure out our moral responsibilities.
And before we jump into those trenches, we have to start by defining what we're even talking about. And that is a huge challenge in itself.
Because we're trying to define something famously private, completely subjective, we're focusing on what philosophers call phenomenal consciousness.
Precisely. The working definition that really still stands as the benchmark was put forward by Thomas Nagel way back in 1974.
And what was that?
He defined it as states of mind with a qualitative feel. It's that subjective, what it is like aspect of experience.
So like the unique way the color red registers in your mind.
Or the searing private feeling of pain, or even the specific sonic quality of thunder. If an animal has phenomenal consciousness, it just means there's fundamentally something it is like to be that animal.
Even if we can never, ever access it ourselves.
Exactly.
Okay, so once we have that definition, the whole philosophical landscape immediately seems to break down into two core questions, and these seem to guide everything we're going to discuss.
They do. These were formalized by a philosopher named Allen in 1998. First is the distribution question. Which animals are sentient?
Right. And that forces you to immediately confront the structure of consciousness itself.
It does. I mean, does it exist on a gradient? Does it come in degrees where some animals are just more conscious than others, sort of like a spectrum of baldness?
Or is it binary?
Or is it binary, like pregnancy? Either you are or you aren't. There's no in between.
The difference between those two options is immense. Because if it's a gradient, then the question of where we draw a moral or legal line becomes completely arbitrary, doesn't it?
Totally arbitrary.
Yeah.
We could spend a century arguing over whether a fish is 10% conscious or 40% conscious.
So what's the second big question?
That is the phenomenological question. What kind of consciousness do they possess? This is the issue of knowing what it is like for a bat navigating in the dark or a bony fish swimming in the deep.
Or an octopus shifting its coloration.
The gap there, our profound ignorance, is arguably the quintessential formulation of the problem of other minds. It's just massive.
And that gap is made even more complicated by the sheer biological diversity we're facing.
Exactly. You can't just apply one single theory uniformly across the board. For instance, the zoological category of fish is just vastly heterogeneous.
A shark is not a salmon.
Not at all. A shark is evolutionarily distant from a salmon, and a trout is different again. So we have to consider the possibility that for some species, their experience is indeed like nothing at all, as some skeptics have argued.
But on the flip side, we also have to consider cases where we have some, first-hand acquaintance.
Sure, like shared mammalian traits, which might make the leap to analogy just a little bit easier.
This inherent difficulty, it leads to a fundamental philosophical crossroads, a real fork in the road.
It does. When you tackle animal consciousness, should you first sort out a metaphysical theory defining what consciousness is at its core, say it's this specific brain activity or it's a type of information processing, and then you apply that definition across all species?
Or do you do the opposite?
Or conversely, do you prioritize epistemology? How we know or gain evidence of consciousness, looking at behavior, responsive structure, and only then attempt to kind of backfill our metaphysical definition.
And because the mind is so internal, and because the history of philosophy is, let's be honest, littered with failures to define the mind absolutely, many researchers just concede that we have to start with the evidence.
We have to start with how we gather evidence.
Which is exactly where we're focusing next.
Yeah.
Since the problem is so intractable, particularly when we move beyond our own species, our mission for the next segment is to explore the main philosophical responses to that second approach. Epistemology first. How do we even begin to investigate consciousness in beings that just cannot tell us about their experience?
Well, the problem of attributing consciousness isn't an animal-specific issue to begin with.
Right. Within our own species, we struggle with uncertain cases all the time. Patients in vegetative states, fetuses, people emerging from anesthesia.
But when we move to non-human animals, the difficulty is just compounded so severely by these vast differences in anatomy, environment, and behavioral needs.
And the philosophical challenge here, as it's described in the literature, is navigating what are called the twin perils. It's like sailing between the mythical monsters Scylla and Charybdis.
A perfect analogy. On one side, you have to avoid anthropomorphism.
And that's Scylla.
That's Scylla. It's multifaceted and resilient. It's the mistake of too easily attributing human feelings, beliefs, sophisticated emotions, just based on superficial similarities in behavior.
Like when a cat chases a laser pointer, it's not necessarily calculating trajectories.
Right. It's much more likely acting on a deep-seated instinctual movement tracking program.
And on the other side, what's Charybdis?
On the other side, we have to avoid excessive skepticism. Charybdis is described as obliterating. This is the danger of denying consciousness even when there's compelling evidence suggesting it's there, simply because the creature doesn't meet some impossibly high standard of human-like behavior or anatomy.
It sounds like all our ethical decision-making hinges on finding a middle path, yet the source material says that generally accepted, ironclad methods for navigating these two perils are seriously lacking.
They really are.
So historically, how did science try to correct for this inherent human tendency towards anthropomorphism?
The field tried to impose some discipline using a very, very influential principle known as Morgan's canon. It was formulated by C. Lloyd Morgan back in 1894.
And this was a reaction to something.
A direct and necessary reaction to these overly generous anecdotal reports, stories that anthropomorphize pets or captive animals, attributing complex planning to what were probably just simple learned habits.
So what did Morgan's canon actually state?
It states that, and I'm quoting here, "In no case may we interpret an action as the outcome of the exercise of a higher psychical faculty if it can be interpreted as the outcome of the exercise of one which stands lower in the psychological scale."
Okay, so always default to the simplest possible explanation for the behavior you see.
That's the core mandate.
Yep.
And it was widely adopted as the scientific study of animal cognition began, especially during the rise of behaviorism. It compels researchers to rule out simpler mechanisms first, like tropism, a purely physical turning toward a stimulus or basic associative conditioning before they're allowed to invoke sophisticated, complex internal states like belief, desire, or long-term planning.
I can see how that enforces scientific rigor, but is it just a principle of parsimony? Always choosing the simpler theory? Or is it something more foundational, like Occam's razor?
That's a key academic debate. Some, like the philosopher Elliot Sober, have argued it is a specific methodological application of Occam's razor within psychology. You just eliminate unnecessary entities like complex mental states if the simpler mechanism, like association or reflex, explains the data just as well.
But I imagine critics worry it's biased.
They do. Critics worry that Morgan's canon is applied with a bias, making it excessively difficult for animal cognition to ever level up in scientific explanation. But regardless, it fundamentally shaped the approach. If behavior can be explained by mere association, you shouldn't assume sophisticated thought.
But Morgan's canon deals primarily with cognition, things like beliefs, learning, decision-making. When we talk about phenomenal consciousness, that subjective, qualitative feel, we run into an even deeper, more radical form of skepticism.
Yes, sometimes called the harder problem of consciousness, and articulated most famously by Ned Block.
Block's skepticism is truly profound.
It is, because it trades on our intuitions about physical identity. He acknowledges that we start with the human case. So, if consciousness is tied intimately to our specific neurological structure, how can we possibly have grounds for attributing it to beings that are physically and neurologically vastly different from us?
Even if the animal behaves exactly like a human would.
Yes. Block addresses this idea of a common-sense functional isomorph, an animal or even a machine that acts, responds, and learns exactly as if it has experiences. But Block argues that even in that perfect behavioral mirror, there remains a prima facie doubt. Functional similarity alone is just not sufficient if the underlying physical structure is radically different.
This fundamentally rejects pure behavioral evidence as proof of consciousness. It suggests that studying the neural architecture, the hardware, matters more than the observable behavior, the software.
Absolutely. Block implies that the study of animal consciousness cannot proceed with any confidence without close scrutiny of neurological similarity. And the stakes here are immense.
Why is he that?
Well, if Bloch is correct and neurological identity, or at least close similarity, is a necessary precondition for a confident attribution, then the hope of merging first-person accounts, which are fundamentally human, with scientific methods to get testable hypotheses about private experience in a dissimilar species, that whole project might just be incoherent.
So we're stuck. We have our inherent anthropomorphic bias, that's Scylla. We have the philosophical rejection of behavioral evidence, that's Charybdis or Bloch's view. And we have a total lack of consensus on the criteria.
And that perfectly sets the stage for the three main philosophical strategies that try to bridge this huge epistemic gap: analogical arguments, inference to the best explanation, and perceptualism. These are the tools that were developed to try and get a handle on the problem.
Okay, let's start with the most intuitive one, the argument from analogy. This strategy uses comparative reasoning to ground our knowledge of other minds, and its use has, well, ancient roots.
It does. Though it's often formalized by figures like John Stuart Mill, the basic concept is much, much older.
You mentioned Augustine earlier as an early proponent.
Yes, Augustine provided one of the earliest and most straightforward expressions of the analogical solution. He observed his own self, how his mind controls his physical body, how he perceives a soul residing within his own life.
And he reasoned from there.
He reasoned that when he sees other bodies moving similarly to his own, displaying similar physical expressions and purposeful action, he can then infer the existence of a life and a soul in those similar bodies.
It's basically the reasoning of a child. If I hurt and you wince, and I know that when I wince I'm hurting, then I can assume you're hurting too.
Exactly. It's highly intuitive, and it forms the basis of our everyday interaction. But if we want to talk about the historical challenges to this idea, we have to turn to René Descartes.
Of course.
His position remains notorious for radically breaking from this intuitive analogical approach.
Descartes, of course, argued that animals are essentially self-moving machines. They lack the incorporeal soul, the res cogitans, or thinking thing. He claimed human behavior requires both a mechanism and a mental substance, but animal behavior is entirely explained by mechanism alone.
They are simply complex natural automatons, and crucially, he had to dismiss all those everyday observations, the dog running eagerly to the door, the cat wincing in pain, as superficial appearances. He needed some rigorous arguments to justify ignoring that intuitive analogy.
So what were his primary philosophical arguments for dismissing the appearance of animal thought?
He offered three interlocking ways to undermine that comparison. First, he simply noted that many animals move in ways that suggest mechanism. He cited the seemingly haphazard, purely physical flight patterns of a butterfly or the swimming of a fish, arguing that these actions don't suggest any internal deliberation.
Oh, what was the second?
Second, he argued based on probability. Art copies nature. Since humans can build complex automatons that mimic life, it's probable that nature itself is just full of complex automatons, and those are the animals.
The third argument, though, that's the one that really separated humans from animals in his mind.
That's right. The third is the argument that language is the only certain sign of thought. Descartes wasn't impressed by an animal just making sounds. He emphasized the creative and flexible aspect of human language.
What do you mean by that?
He argued that no animal, however perfect or well-made, could ever produce different arrangements of words so as to give an appropriately meaningful answer to questions, nor could they use knowledge flexibly in all kinds of situations.
That is a very high bar. He wasn't just looking for communication. He was looking for demonstrated, creative, context-aware reasoning, all done through language.
Precisely. For Descartes, if you cannot demonstrate that creative, flexible linguistic ability, the ability to deal with novelty and produce meaningful responses, then you lack certain proof of thought. And since animals lack this, their behavior, no matter how complex it looks, must be purely mechanical.
But this interpretation is, it's complicated by the fact that Descartes sometimes referred to animal sensations like anger, fear, or hunger. That's led to some historical confusion.
It has indeed. If you read him literally in those isolated phrases, it seems like he accepts phenomenal consciousness in animals. But this clashes so severely with his foundational claim that animals lack the non-corporeal thinking soul, the res cogitans. So to be textually faithful, we have to stick to his core metaphysics.
So the charitable yet textually faithful interpretation of sensation in animals has to be purely mechanistic.
Correct. By sensation, Descartes meant only the physical internal movements. muscle contractions, nerve impulses, or what he called brain commotions. These are mechanical movements of the animal's machine body that would cause a conscious episode if the thinking soul were present.
But in animals, which lack that soul,
The movements remain purely physical and unfelt. An animal's observed fear is just the mechanical preparation for flight, not the felt, phenomenal experience of terror. He explicitly stated that animals lack pain in the strict sense.
this logical consistency, however, disturbing, it connects directly to the historical accounts of his reported indifference toward animal suffering.
It does.
If the creature is just a mechanism having only physical brain commotions, then subjecting it to something like vivisection is merely examining a complex clockwork. There's no genuine suffering to worry about.
Exactly. His conclusion, although morally abhorrent to our modern sensibilities, was a direct rational deduction from his metaphysical starting point. He just denied the analogy. And while his conclusion is generally rejected today, his underlying dissatisfaction with this kind of similarity-based reasoning still holds a lot of weight.
Analogy has profound limitations.
It does.
So let's detail those. What are the key critiques of the analogical strategy?
Okay, first we have the single case problem. The analogy for other human minds is considered weak by many philosophers because you're reasoning from the unique case of your own mind. It's an induction based on a sample size of 1, which is statistically terrible.
Right.
Now, the analogy for animals avoids this a little because we reason from the properties of a large class, all humans, but this introduces a new, challenging question. If we don't need analogy to confirm other humans are conscious, we just assume it, why do we suddenly need analogy when we look at animals?
It suggests we already have a fundamental suspicion of discontinuity. We're already biasing the investigation.
Exactly. Second, the conclusions on analogy are unconfirmable. Unlike inductive reasoning about the physical world, where you can independently confirm that the next swan you see is indeed white, the conclusion of consciousness in another being can never be independently verified. You can never truly get inside another mind.
And philosophers like Ryle argued this really weakens its scientific standing.
Significantly. Third, and this is maybe the most crucial critique ethically, is the risk of chauvinism. Analogy relies explicitly on similarity to us.
And this risks excluding sentient beings that are highly dissimilar to us, like an octopus or a bee or some hypothetical alien life form.
Yes. If we rely on structure or behavior that mirrors human structure, we risk committing unchecked type 2 errors, false negatives, where we deny consciousness to a creature that possesses it simply because its mind is radically alien to our own.
Okay, and finally.
Finally, there's the relevance problem. Even if we accept the idea of analogical reasoning, we just don't know which properties are relevant. Should the comparison factor in shared behavior, shared physiology, shared neural structure, shared evolutionary history?
We don't know what to compare.
Exactly. If we already knew which specific properties counted as the mark of consciousness, the problem of other minds would already be solved. The analogy requires prior knowledge to even get started, which shows its inherent circularity.
Given how profoundly flawed the argument from analogy appears, scientists and philosophers clearly needed a strategy that didn't rely on self-observation or similarity.
They did.
This brings us to the second major epistemic strategy, inference to the best explanation, or IBE.
IBE completely changes the game. It treats internal mental states, whether they are beliefs, desires, or conscious experiences, as theoretical posits.
So they're like genes or electrons or black holes.
Exactly. We don't observe them directly, but they are strongly evidenced, though only indirectly by way of their observable effects.
So the argument is that mentalism, positing that real internal mental causes drive behavior, offers the best, most comprehensive explanation for what we see an animal doing.
Precisely. This requires setting up controlled tests where a behavior explained by a complex mental state is compared against hypotheses explained by simpler, more deflationary mechanisms.
Like basic conditioning or associationism.
Yes. If the animal passes tests that the simpler hypotheses fail, mentalism wins. This is IBE in action, for instance, testing for a cognitive map. If a rat takes an improvised shortcut to a reward, that suggests an internal spatial representation, rather than just a strictly learned sequence of left and right turns.
And IBE has some significant philosophical virtues that analogy lacked.
It does. IBE is inherently anti-chauvinist. It doesn't require the animal to look or act like me. It only requires the mental state to be the best theoretical explanation for its own specialized behavior.
And it avoids the single case problem.
Entirely. It relies on observable, repeatable effects.
But IBE also runs into some philosophical challenges, doesn't it? Primarily related to defining what makes an explanation best.
Indeed. The criteria for judging an explanation best are notoriously fuzzy. We talk about theoretical virtues like simplicity, generality, coherence with existing scientific knowledge, but there's no fixed philosophical scorecard for this.
And there's a persistent challenge in cognitive science about where to draw the line.
A huge one. The difficulty in clearly demarcating between a highly complex associative behavioristic account and a truly cognitivist representationalist account. When does a learn association become a genuine internal mental representation?
And this difficulty is just multiplied exponentially when we apply IBE, not just to cognition, the processing of information, but specifically to phenomenal consciousness.
The qualitative feel.
Right. We have to figure out the causal role of the qualitative experience itself.
This is a deep conceptual hurdle we have to ask. Assuming consciousness has a function, what behavior or outcome is it supposed to explain that an unconscious complex algorithm couldn't also explain?
What are some of the proposed cognitive roles for phenomenal consciousness?
Several have been hypothesized. One prominent idea is that consciousness explains the capacity to adjust for perceptual error, the ability to distinguish between how things look and what is taken to be true.
Can you give an example?
Sure. A conscious creature might register that a stick looks bent in the water, but simultaneously believe that it is, in fact, straight. If a creature can't make that appearance-reality distinction, perhaps it lacks phenomenal consciousness.
Other proposals connect consciousness to sophisticated control.
Yes, proposals link it to adaptive control, rational action, or the capacity to host a centralized representation used to coordinate complex, goal-directed behavior. The issue then becomes, can we design a test that only the presence of the qualitative feel, not just complex information processing, can pass?
Which brings us to the crucial "so what" question, which is often raised by philosophers like Peter Carruthers.
And this question is critical. Do the qualitative features of mental representations offer any added value to explanations of animal behavior? In other words, if an unconscious, highly complex algorithm, a sophisticated, unfeeling mechanism, could achieve the exact same adaptive behavioral outcome, like escaping a predator or finding food, then the qualitative felt aspect of experience is just explanatory surplus.
It's what philosophers call an epiphenomenon.
Exactly. It exists, but it doesn't do anything causally.
And if consciousness is just an epiphenomenon, then IBE for consciousness fails completely, because IBE assumes the mental state is the cause of the action.
Precisely. If the subjective feel offers no functional explanatory power, then IBE for consciousness falls apart. And that forces us back toward reliance on direct acquaintance, the flawed analogical solution, or demanding a neurological correlate.
So let's pivot to the third and radically different approach, which tries to avoid inference altogether. Perceptualism.
Right.
This suggests knowledge of other minds is not a theoretical judgment, it's direct perception.
This school of thought draws heavily on phenomenology, the work of Husserl and Merleau-Ponty. The core idea is that we purportedly just see pain or anger or joy in a wincing face or a joyful leap. We don't infer it. The mental state is directly perceived through the physical expression. The body isn't just a container for the mind, but the mind expressed.
That feels right for human interaction. We react instantly to a sudden gasp of fear. But applying this to a highly dissimilar animal, that requires extraordinary interpretive skill.
It does, and that's where the philosophical challenges start to mount. First, unconscious inferences. We are highly social creatures, built to rapidly process social cues. How can we possibly rule out that the judgment we think is direct perception is actually a blindingly fast, sophisticated, unconscious inference? The speed of the judgment doesn't mean it's not an inference.
Okay, what's the second challenge?
Accounting for error. If perception is direct, how do we explain misattributions? The classic thought experiment involves mistaking a sophisticated automaton, a blockhead, for a conscious entity. We'd be directly perceiving consciousness that isn't actually there.
How do perceptualists handle that?
They usually argue that these judgments rely on background knowledge that sets our default assumptions, helping us recognize the blockhead as atypical when we look closer. But this fails spectacularly when we consider animals highly dissimilar to us. What are the default assumptions for a beetle or a deep-sea fish? We have no settled framework, which leads to vast variance in our attributions.
And the third challenge, access. Mental states are internal and subjective. We can't examine them from different angles or perspectives, which is fundamental to how perception works in the physical world.
Think of scene segmentation. If you see a cat's head poking out from under a blanket, you segment the scene and infer the rest of the cat's body is there, hidden from view. You perceive the whole cat.
Right.
But we can't look at a hidden mental state, a belief or a feeling from a different angle, or move closer or touch it to confirm it exists. Mental states simply aren't open to that kind of perceptual verification. So given these difficulties, many philosophers concede that some form of inference in attributing mental states just cannot be avoided.
We've spent a lot of time on epistemology first, how we know. Now we should pivot to the alternative, the metaphysics-first approach. This means starting by defining what consciousness is at a fundamental level, and then applying that fixed definition to the animal kingdom.
And this approach carries the heavy burden of philosophical theory choice. The field is completely fragmented, and we immediately run into a kind of circularity.
Which is what?
Should our highly intuitive, pre-theoretical judgments about animal minds, like the certainty that a dog feels pain, should those constrain our choice of a metaphysical theory? Or should we accept that a scientifically plausible theory, once we've defined it, might force us to reject those folk judgments?
A real chicken-egg problem. Let's look at the two major theoretical camps, starting with the ones that focus on the brain's hardware.
Right, neuroreductive approaches. The core of this strategy is often called the neural correlate of consciousness, or NCC. It seeks to isolate the neural mechanisms that are minimally sufficient for phenomenal awareness. Researchers, following people like Crick and Clark, look for patterns of brain activity that are present when a subject is aware of a stimulus, but absent when they are unaware.
And once that NCC is identified in humans, the move to animals relies heavily on similarity-based reasoning or analogy, but at the structural level.
Exactly. And the chief dividend from this reasoning is that the human neocortex is sufficient for consciousness, especially thalamocortical regions working with subcortical structures. This provides a very strong similarity-based case for consciousness in all mammals who share highly homologous or ancestrally shared hardware.
The structure is similar, so the functional outcome is likely similar.
That's the argument.
But the real challenge begins when we look at species without a neocortex, which brings us to the subcortical debate, or the midbrain view. This suggests consciousness might reside much lower in the brain.
The midbrain view claims that subcortical structures alone might be enough, which would dramatically widen the distribution of consciousness to animals lacking a fully developed neocortex, like many fish or amphibians.
And this view is often supported by some very specific human cases.
Yes, observations involving children with congenital hydranencephaly, individuals born apparently without a cortex, who nonetheless showed signs of emotional responsiveness and conscious awareness. This led some to conclude that the midbrain or upper brainstem could host phenomenal awareness.
If the midbrain is all you need for consciousness, then the distribution question is settled in favor of a huge range of animals. But the sources note a crucial critique of this view, warning against hasty extrapolations.
The critique of the hydranencephaly cases is vital and complex. First, the source notes that the individuals in question weren't truly decorticate. They likely had some residual cortical resources. Second, the brain is highly plastic, especially early in development.
Okay, and why is that so important?
The crucial point is that neuroplasticity allows midbrain neurons or other subcortical structures to be reprogrammed to take up functions that would normally belong to the cortex.
So we can't conclude that the cortex is unimportant. We can only conclude that its function has moved to a new address.
That's a perfect way to put it. The critique states that cortical functioning isn't shown to be unimportant just because it has taken up residency at an unusual address. And furthermore, these observational cases often lacked necessary confirmation, like detailed postmortem autopsies. The consensus remains heavily reliant on the cortex being central.
Let's move now to representationalism, the software approaches, which shift the focus from what the brain is made of to what the brain does.
Right. Consciousness is located in the functional roles of mental representations. And we have two major types here. First-order representationalism, FOR.
And this is a functionalist approach.
Yes. Consciousness reduces to mental representations that play a specific cognitive role, particularly in integrating input and influencing output. This is aligned with Bloch's access consciousness information that is widely accessible for reasoning and behavioral control. FORFERS essentially requires the representation to be poised to make a difference to belief and action.
What are the implications of this definition for the distribution question? Who gets to be conscious?
FORFOR is highly inclusive. It straightforwardly implies consciousness in any animal with a sophisticated cognitive economy. This includes the usual suspects, mammals, birds, but also many others like bony fish, reptiles, cephalopods, and possibly even specific sophisticated invertebrates like the honeybee.
So if a mental state is doing the functional job of integrating information and flexibly guiding action, it's conscious.
That's the theory.
This sounds very appealing, but it opens the door to a huge criticism: overgenerosity. Where do you draw the line between a sophisticated unconscious machine and a conscious animal?
The challenge posed by autonomous vehicles highlights this perfectly. Consider an advanced F-16 drone or a self-driving car. The philosopher Locke notes that a drone can figure out the safest path to a target, respond flexibly to unforeseen threats, and update its information states rapidly.
And these information states are certainly poised to make a difference to belief and action. They meet the functional definition of FOR.
They do, but our intuition screams that the drone is not conscious. It is a highly complex algorithm, not a subject of experience.
So if the drone meets the functional criteria, yet we deny it consciousness, it really pressures the very definition of what counts as an attitude-like state.
It forces F-Venara theorists to add increasingly complex requirements, perhaps demanding certain biological components or specific types of representation to exclude the non-conscious machines, which really just dilutes the original functional definition.
This leads us naturally to the second major software theory, which tries to fix this overgenerosity problem by demanding a higher level of internal processing. Higher-order theories.
HO theories propose that a mental state is conscious only if the subject is aware of it via a second higher-order mental state. There's higher-order perception, HOP, which posits an inner sense, a form of inwardly oriented perception, much like seeing something in the physical world, but directed at your own mental state.
Is HOP friendly to animal consciousness?
Potentially, yes, if that inner sense doesn't require complex conceptual thought. It's hard to define what this non-thought awareness is or which animals would satisfy it, but it's less restrictive than the alternative.
And the alternative is the much more restrictive and pretty controversial higher-order thought, HOT theory.
HOT requires the subject to token a thought about the mental representation. For a representation to be conscious, the subject must be thinking, implicitly or explicitly, something like, I am seeing red now, or I am feeling hungry. This imposes a massive cognitive requirement.
I can see why this is so restrictive.
Yeah.
A major objection is that most animals, and human infants for that matter, they lack the requisite concepts, the very idea of a mental representation or seeing, to form such thoughts.
That's the consensus objection. If HOT is correct, phenomenal consciousness would be restricted to a vanishingly small field, perhaps only humans, and maybe a few of the great apes like chimpanzees, though even the consensus on EP consciousness is low. Many HO proponents, like Carruthers, just accept this denial of consciousness to non-humans as a necessary cost of the theory.
Is there any philosophical attempt to mitigate this extreme chauvinism?
Yes. Some theorists, like Lurs, have suggested that we might lower the conceptual bar required for tokening HOTs in animals. Perhaps less sophisticated concepts like just the concept of looking or seeing might suffice, rather than the complex concept of mental state. But this remains highly controversial. It's an ongoing struggle to try and make the HOT theory palatable without undermining its core requirement for abstract conceptual awareness.
The philosophical struggles we've just discussed, analogy versus IBE, hardware versus software, have profound real-world consequences, especially for animal welfare and moral policy. So let's look at how these debates surface in specific case studies, starting with a major attempt to forge a consensus. The Cambridge Declaration on Consciousness from 2012.
This was a landmark statement. It was made by a group of prominent neuroscientists who unequivocally supported the idea that, quote, humans are not unique in possessing the neurological substrates that generate consciousness.
And they extended this to other animals.
They explicitly extended this to all mammals and birds and many other creatures, including octopuses.
That sounds like a powerful endorsement of widespread consciousness. You noted earlier that the rhetorical strategy of the Declaration has been subject to some critique.
It has. The Declaration made the point that the absence of a neocortex does not appear to preclude an organism from experiencing affective states. Since the neocortex is a mammalian characteristic, the natural, logical broadening of that statement should be to non-mammalian vertebrates.
But that's not what they did.
Instead, the Declaration used the much broader term non-human animals. This rhetorical understatement makes the declaration appear less divisive than it is, because it quickly jumps from strong evidence in birds to highly controversial evidence in invertebrates, like octopuses.
And the inclusion of cephalopods is the anatomical ticking point.
Exactly. It is highly doubtful that octopuses possess structures that are homologous to even mammalian subcortices, let alone a neocortex. While the declaration mentions behavioral indicators in insects and cephalopods like attention, sophisticated sleep patterns, complex decision-making, it throws into sharp relief that perennial question. Is behavioral evidence alone persuasive enough to argue for consciousness, especially when the underlying neuroanatomy is so profoundly different?
This uncertainty leads us directly into the critical practical debate, the problem of animal pain. This dictates our moral and legal frameworks concerning how we treat farmed and captive species. We have to distinguish conscious pain from mere protective reflexes.
That distinction is absolutely vital. Conscious pain is far more complex than simple nociceptive stimulation, the signaling of tissue damage. In humans, pain relies on sometimes competing subsystems. We have the sensory component, where exactly does it hurt, how sharp is it, and the affective motivational component.
And that's the suffering part.
That's the emotional suffering, the desire to escape, the motivation to avoid that sensation in the future.
And protective reflexes, like pulling your hand off a hot stove, can happen without any consciousness at all.
Precisely. Nocifensive flexion, the protective withdrawal, can occur entirely without awareness. The literature provides some striking examples that favor these deflationary accounts. Think of a dog's leg scratch reflex.
Okay.
A dog with a detached spinal cord can still locate and scratch the precise spot of an irritant on its flank. That shows complex coordination occurring entirely below the level of conscious feeling.
That is a powerful example of complex behavior without consciousness. What other deflationary evidence exists?
We see insects ignoring severe injuries, continuing to feed or mate even when their abdomen is cut in half, suggesting their survival mechanisms are highly modular and autonomous. Similarly, elasmobranch fish, like sharks and rays, have been observed to appear entirely unperturbed by severe injuries.
So the nociception is present, but maybe not the suffering.
It suggests the affective motivational component that constitutes felt suffering might be absent. These examples suggest that survival behavior can be automated, reflexive, and unconscious.
So if that's the evidence for an unconscious pain response, what specific behaviors point toward the presence of conscious pain?
We look for adaptive behaviors that go beyond simple reflexes and suggest centralized, complex decision-making. These include behaviors like actively guarding an injured limb for a long time, limping strategically, reducing activity overall, or actively seeking out analgesics or quiet, private spaces to recover.
These behaviors require integration, memory, a change in motivational state.
Yes, and furthermore, neuroanatomically, correlational evidence in humans strongly implicates specific cortical structures, the anterior cingulate and insular cortices, in felt affective pain. This provides the basis for strong structure-function arguments for conscious pain in mammals and birds, who share similar neural architecture.
Let's zoom in now on the species that generate the most controversy, beginning with the fish and reptile debates.
Fish remain a point of intense controversy. Skeptics like James Rose cite the absence of a neocortex as definitive proof against fish consciousness. However, proponents argue that teleost fish, so bony fish like rainbow trout, do possess nociceptors and show strong behavioral responses to noxious stimuli. They suffer cognitive impairments when injected with acid, for example.
And crucially, they also respond to painkillers.
They respond favorably to painkillers. This indicates that while the underlying anatomy is different from ours, some level of sophisticated, integrated processing, suggesting a motivational change beyond mere reflex, is at work.
What about reptiles? Lizards, snakes, they also lack a neocortex.
In many reptiles, the evidence suggests a high degree of modularity. They often exhibit complex behaviors driven by fixed action patterns, or FAPs, which are essentially tightly scripted automatic routines.
Can you give an example?
The anecdote of the snake hunting routine illustrates this well. Even when coiled around prey, the snake relies heavily on chemical cues, like smell and taste, and random probing. It sometimes ignores proprioceptive feedback. It doesn't seem to have a centralized, flexible model of its own body position relative to the prey.
So the behavior is highly scripted.
Very scripted and inconsistent with models that require a centralized, flexible representation of the world.
Moving to the true invertebrates, The cephalopods, especially the octopus, often lead the discussion because of their startling intelligence.
Octopuses are famous examples of high intelligence. They're adept learners, notorious escape artists, capable of displaying complex, creative problem solving. We have all these anecdotes of resourcefulness that seem to demand high-level cognition.
But again, we have to apply Morgan's canon and IBE rigorously.
We do. And their neuroanatomy is radically distributed. Over 2/3 of their neurons are in the tentacles, which are capable of operating semi-autonomously.
Their intelligence is decentralized.
Yes. This distributed nature really complicates the search for a unified neural correlate of consciousness. Furthermore, while they display complex social behaviors like various mating strategies, these can often be fully explained by evolutionary game theory and frequency-dependent fitness.
Meaning the behaviors are automatic.
They're automatic, optimized genetic adaptations competing in a nominal sense, rather than necessarily requiring consciousness or high-level cognition to execute. We need compelling evidence for the qualitative experience, not just for clever behavior.
Finally, we have to consider insects, crustaceans. Some theories have suggested insects might be sentient due to neurological similarities to the mammalian midbrain.
This hypothesis exists, notably from Barron and Klein, but the majority of complex behaviors we see, spiny lobsters navigating home from novel locations, crabs detouring obstacles, honeybees communicating complex spatial data, can be accounted for by powerful, automated, domain-specific competencies.
So we're always brought back to that functionalist challenge.
Yois. A very good GPS or a highly efficient face recognition system is not conscious. The complex behavior reflects powerful, unconscious algorithms honed by evolution, and absent a strong NCC or compelling evidence of effective states, skepticism remains very strong.
This deep dive has truly revealed the massive tension at the heart of this field. We've seen the fundamental difficulty of obtaining secure knowledge. All those epistemological hurdles clash violently with the desire for a single comprehensive definition of consciousness, the metaphysical quest.
And this is not just an academic exercise. The field is enormous, and it's rapidly expanding. The structure-function arguments we discussed, comparing neural architecture between species to infer shared cognitive functioning, are becoming increasingly important in settling the massive moral stakes. Philosophical theories about how consciousness works are directly feeding into scientific frameworks that inform public policy.
We established earlier that the problem of other minds, especially in highly dissimilar non-humans, might be impossible to solve with absolute certainty. Where does this leave us regarding our ethical responsibilities?
Well, if we accept that perfect certainty regarding the qualitative experience of pain or awareness may be fundamentally unobtainable for creatures highly dissimilar to us, then the conversation has to shift. It has to shift away from demanding absolute proof and toward mandating policy based on risk assessment. We have to ask, at what point does sufficient evidence, even if it's indirect, even if it's based only on the inference to the best explanation rather than definitive proof, at what point does it mandate a fundamental shift in our ethical and policy treatment of a species? Should the risk of inflicting suffering on a potentially conscious creature outweigh the burden of proof required for absolute certainty? That philosophical decision is perhaps the most important choice we face as the distribution of consciousness remains contested.